some facts about auroras behind the northern and southern lights. It is viewer's choice this week, and this topic was picked by Alex R.S. Thank you, Alex, for picking this topic. I have this book to whisper to you, and then I have this book, which is kind of awful, but the pictures are so pretty. I thought we'd just look at the pictures in this book. But this book has a lot of information if you wanted to know more about auroras and why they happen. Just keep watching. Auroras. What are auroras? Auroras are beautiful. Look at this. They are natural displays of colored light that sometimes appear in the night sky. They occur mainly in the northernmost parts of the northern hemisphere and the southernmost part of the southern hemisphere. Auroras in the northern hemisphere are called the northern lights, or aurora borealis. In the southern hemisphere, auroras are called the southern lights, or aurora australis. My chair's really squeaky tonight. Apologies. Auroras are named for Aurora, the Roman goddess of the dawn. Auroras take many shapes and forms, with arcs and rays of colored light being the most common. The light may also look like shimmering curtains, bands, waves, or clouds. An aurora constantly changes shape as the light moves across the sky. The light also may brighten and fade. First time I saw aurora, it looked like this. I'll tell you more about my experience with aurora borealis at the end of the video. Let's just read the book. Beautiful forms. Auroras often look more clearly defined when they appear closer to Earth's surface. They seem to fade away as they appear farther up in the sky. Different aurora forms have different names. In the coroniform, rays seem to meet overhead in a star-like shape. In the flame type, tongue-like rays ripple upward. Vertical rays rising from curving bands are called draperies, which look almost like curtains. The uniform arc is the most stable form of aurora. It can sometimes last for hours without seeming to change in shape. However, most aurora forms move. Their movement is often described as dancing. Auroras come in many colors, including red, yellow, green, blue, and violet. However, the most common colors for auroras are light green and pink. Looking for auroras. Auroras occur throughout the year. However, the best time to see them is in the winter time. The seasons happen at different times of the year in the northern and southern hemispheres. This is because of the way sunlight falls on different parts of Earth in the course of a year. Ideal months to see auroras in the northern hemisphere are from November through February. So I gotta itch my face real quick. In the southern hemisphere, it is usually best to see auroras during the months of May through August. The northern lights can be viewed across northern Canada and Alaska, Greenland, Scandinavia, and Russia. The southern lights are not often seen because they occur mainly over Antarctica and the southern Indian Ocean. However, some displays might be visible in parts of New Zealand, southern Australia, and the southernmost parts of Chile, Argentina, and South Africa. Auroras can sometimes be seen outside of the polar regions. In the northern hemisphere, they have been seen as far south as 40 degrees latitude. Denver, Colorado, and Philadelphia, Pennsylvania are both at about 40 degrees latitude. force of metal that can pull certain types of metal toward itself. You might not guess it, but Earth is a giant magnet. We have Earth's magnetic field to thank for auroras. Magnetism is a basic force of nature, like electricity and gravity. It happens when tiny particles called electrons behave in a certain way. All objects in the universe are made up of tiny atoms. Atoms in turn are made up of electrons and other particles called neutrons and protons. Electrons have a negative charge, while protons have a positive one. Charge is an amount of electricity related to the balance of electrons and protons in an object. The electrons spin around the atom's nucleus, which contains the other particles. The spinning electrons form tiny magnetic forces. All the tiny magnetic forces from the electrons add up to make the object one big magnet. Every magnet has two opposite poles or ends. These are called a north pole and a south pole. North poles attract the south poles of other magnets, but they repel other north poles. Likewise, south poles attract north poles, but they repel other south poles. The magnetic forces between the two poles of a magnet create a magnetic field. This is the area affected by the magnet. Like all magnets, Earth has a magnetic field. Earth's north and south magnetic poles are near, but not quite on its geographic north and south poles. The geographic poles are the ends of Earth's axis. The axis is a line around which Earth spins. The planet's magnetic field can be illustrated by lines that connect the magnetic poles. They curve out and around the edges of the field, forming closed loops. Earth's magnetic field. Scientists believe that huge currents of hot liquid metal flowing in the planet's core create Earth's magnetic field. The field's position occasionally reverses. This means that the north and south magnetic poles switch roughly once every million years. Earth's magnetic field shields the planet by steering and trapping electrically charged particles, such as the stream of protons and electrons from the sun. This stream of particles is called solar wind or solar plasma. The particles in the solar wind travel about 1 million miles or 1.6 million kilometers per hour. They reach Earth in a few days. Once trapped, the particles travel in a corkscrew pattern and basically bounce back and forth between the poles. Some particles go into Earth's upper atmosphere. There, the particles hit atoms. This causes a glowing display of color to appear in the sky. The display is an aurora. Wow. It's like a firework. The region of space in which Earth's magnetic field traps particles from the solar wind is called the magnetosphere. Many of the charged particles remain trapped there. Most of these particles can be found in two regions called the Van Allen belts. These are located mainly between 5,000 and 20,000 miles, or 8,000 and 32,000 kilometers. million kilometers into space. The magnetic field helps protect our planet. It keeps most of the solar wind particles from striking the atmosphere. Without the field, the solar wind might slowly wear away much of the planet's atmosphere. See them here. Magnetic field. Now about. I think that's how that works. Earth's atmosphere. The atmosphere is the layer of gas that surrounds Earth. It is often called air. Other planets also have atmospheres, so do some large moons. Earth's atmosphere is made up of several gases. The gases are held close to Earth by gravity. Near Earth's surface, the atmosphere is about 3/4 nitrogen and 1/5 oxygen. At higher elevations, it is mostly hydrogen and helium. Scientists divide the atmosphere into 5 regions or layers. The layer closest to Earth is the troposphere. The stratosphere is next, then the mesosphere, then the thermosphere, and finally the exosphere. Auroras mostly occur in the thermosphere. This layer extends from about 50 to 300 miles, or 80 to 480 kilometers above the Earth. That's gorgeous. Wow. Causing bright colors. Look at that red. So bright. It's like blood red. Earth's magnetic field captures charged particles brought by solar winds. There, the particles can crash or collide with oxygen and nitrogen atoms. This causes the atoms to break up and lose electrons. The atoms become charged, having gained or lost an electron. The ions give off energy called radiation. We see this energy as the different colored lights of an aurora. Green or red light is produced when particles collide with the oxygen in air. Green lights occur at lower heights than red lights. Nitrogen collisions tend to produce blue and purplish light. Wow. Solar activity and auroras. Magnetic activity within the sun causes disturbances on the sun's surface. These disturbances are called solar activity. Solar activity includes sunspots and violent eruptions, such as solar flares and coronal mass ejections, or CMEs. A single CME can contain as much mass as a mountain. Solar activity follows a cycle that takes about 11 years. During a cycle, the numbers of sunspots and other disturbances increase to a maximum and then decrease again. Once each 11-year cycle, the north and south poles of the sun's magnetic field flip their orientation. Auroras are more active when there is a lot of solar activity. The increase in activity also increases the chance that an aurora will appear in the sky beyond Earth's polar regions. Like solar activity, aurora activity follows an 11-year cycle. Unearthly auroras considered. Auroras occur on Jupiter, Saturn, Uranus, and Neptune. Sorry for my ankle popping there. Uranus and Neptune. These planets all have atmospheres and strong magnetic fields, which which are necessary for auroras to occur. Each planet's aurora looks different. This is because each planet's atmosphere is different. Saturn's auroras produce mainly invisible ultraviolet or UV light, which can only be seen from Earth with special telescopes. Earth's auroras last for minutes. Saturn's auroras can last for many days. Jupiter has huge auroras at its poles that seem to always shine. Can you see them? They're very purple. They are fed by particles from the Sun as well as from Jupiter's moons. Jupiter's moon Io also has auroras. The particles that cause the auroras come from volcanoes on Io. The auroras on Jupiter may be larger than Earth itself. That's a lot to wrap my head around. Understanding auroras. The beautiful and mysterious lights of the auroras have fascinated humans for thousands of years. Descriptions of the lights are found in writings and folklore of many cultures across history. In some traditions, the lights were revered as spirits of the dead or as a sign of good news. In other cultures, they were feared as a sign of looming disaster. Today, people know there are scientific reasons for why auroras happen. However, scientists continue to study auroras to learn more about them. Observatories in Antarctica and the Arctic allow scientists to see auroras and record observations with the latest equipment. Scientists on the International Space Station study auroras from above Earth's atmosphere. Other scientists launch rockets into auroras to study their particles. Look at the aurora from space. So cool. One reason that people study auroras is because it is a good way to learn about things that affect space weather, such as the solar wind. Space weather can cause big problems for people. It can destroy satellites that are used for wireless communication on Earth, or disturb the signals satellites send. Many things people depend on every day, such as cell phones and navigation systems, rely on satellites. Solar storms may even cause electrical power outages on Earth. Scientists also study auroras because they are curious about them. Perhaps they wonder if auroras occur in other places in the universe, or perhaps they wonder what specific reasons cause one aurora to look just a bit different from another aurora. Perhaps for some of the same reasons, tourists and scientists continue to go to the coldest areas on Earth to see the glowing, dancing lights. I think that's the end of the book. Yeah. Alright, let's look at the pictures in this book. Northern Lights. That cool. see some of the stars through it. This is so pretty. Greens and purples in the woods in the winter time. Big satellite. You can see the aurora in the background, green and glowy. And last picture here. Gosh, looks like it's erupting. Because the horizons right here looks like they're on top of a mountain. So it's just taking up the whole sky. So yeah, I've seen the aurora twice in my life, which I'm so blessed because that's always been such a bucket list thing. Me living in San Francisco, we don't see aurora at all. I'm sure it's the end, yeah. So the first time was the first time I visited Washington State, and there just happened to be a massive solar storm that week. Loud car outside agrees. I think that's a motorcycle. And we went out to see, oh gosh, what was it? I want to say it was like a movie or something. I don't know. But on the way, we were driving back, and I'm like, oh my gosh, the sky is pink. The whole sky was like this. So I didn't see any curtains or ripples or anything, but the whole sky was glowing pink. It was amazing. Then we moved to northern Idaho, where auroras occur at least maybe 4 or 5 times a year. But so far I've only seen it once since we moved here a year and a half ago. And unfortunately we live right next to a big old lake, and it gets very, very foggy at night in the winter time. So the couple of times it's happened, I look outside and the whole sky is covered in clouds and fog and you can't see anything. But there is one time that you could kind of see it, and if I remember, I'll throw the picture up here that I took with my phone of the sky glowing pink, and I was so tickled by it. Even though it was really faint and it was still really foggy and cloudy outside, you could still see the glow of the aurora above my neighbor's house. Where I live, there's a bunch of trees, so you can't look up from my windows or from our yard. I had to walk out a bit into the neighborhood to see the aurora. But I also picked these nails because I thought they kind of looked like auroras. Can you see the shine? Isn't that so pretty? These are so cute. But thank you so much for watching. I hope that you found this video to be relaxing and